Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into the deep past, into the still warm footprints of creatures so ancient, so vast in time and form, that they feel like a dream even when they're real. This is a story of the dinosaurs, not just their rise or their fall, but their quiet echo through the birdsong outside your window. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into deep time together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. So, let us begin, not with the roar of a tyrannosaurus, but with a whisper in the stone. Imagine, if you will, the Earth long before names, before continents drifted to their familiar outlines, before flowers opened, before there were birds to sing in the morning or grass to lie in. Picture instead a land cloaked in ferns the size of buses, skies without wings, and forests humming with insects as large as your hand. In this ancient hush, the first dinosaurs emerged, not with a crash, but with careful steps on soft, muddy ground. When we think of dinosaurs, it's often the titanic, the thunderous, great beasts that stomp through jungles, jaws open wide, scales glittering like armour. But the beginning was not so grand. The earliest dinosaurs were small, light, and fast. They darted through underbrush rather than crushed it. They were survivors first, conquerors second. The Earth that birthed them had recently been through something terrible. A mass extinction, the worst in history, had wiped out nearly 90% of all species. Oceans had grown anoxic, land had withered, and the world itself had fallen strangely silent. But silence does not mean the end. It often means that something new is preparing to rise. From this silence, the ancestors of the dinosaurs emerged. They did not dominate immediately. For tens of millions of years, they were just another curious experiment in the vast laboratory of evolution. Long-legged reptiles with hips that hinted at what was to come. They were not the biggest, they were not the strongest, but they were mobile, upright, and oddly adaptable. And in time, they would grow. The story of dinosaurs is not just one of power or size. It is a story of transformation, of bodies reshaped by time and necessity, of feathers where once there were scales, of bones made light to rise into the air. If you listen carefully, you can still hear them. Not in thunderous footfalls, but in the soft cooing of a pigeon on your windowsill, in the cautious peck of a sparrow, in the silent glide of an owl through twilight. Every bird is a dinosaur still travelling through the corridors of time, and so tonight, we will follow that journey, gently, patiently, not just through the Triassic and Jurassic, but through riverbeds and bone beds, through volcanic ash and impact craters, through the flowering of plants and the fading of worlds. We will meet the giants and the caretakers, the predators and the parents, the tyrants and the survivors. We will meet Stegosaurus, who wore plates like sun-catching sails, Diplodocus, who stretched longer than a subway train but swayed gently as a reed. We will peer into the sharp eyes of Velociraptor, feathered and nimble, and we will listen to the soft clatter of eggs being tended in a shallow sun-warmed nest. And when the end comes, as it always must, we will sit beside them as the sky grows dark, as the ash begins to fall. We will not rush through their extinction, nor dramatise their final breath. We will sit quietly and witness it as part of something larger. Because even the end was not the end. The asteroid impact that marked the close of their era did not erase them. It changed them. It filtered their future through the sieve of survival. What emerged, blinking and trembling, was smaller, lighter, and capable of flight. Those who had wings survived where the giants could not. The ground could no longer hold such mass, but the sky, it welcomed their lightness. And that is how we come to this moment, to you, here, now, in a room lit softly, listening to stories from a time before stories. You, a mammal descended from burrowing survivors, and outside, somewhere, a bird, the last dinosaur, ruffling its feathers in the wind. The past is not gone. It breathes beneath our feet. It flies above our heads. It perches quietly in the trees and sings the song of a world that once belonged to thunder, but now hums with wings. Let's begin. If you could travel back through time, not just centuries, not even mere millennia, but hundreds of millions of years, and set your feet down gently upon the surface of the earth, you might not recognize the world around you. The sky would still be blue, the oceans vast and briny, but everything else would feel wrong, like waking up in a dream that wears the shape of your hometown but none of its spirit. We begin not with dinosaurs, but with their absence, with a silence so deep it echoes. This is the world after the Great Dying. Roughly 252 million years ago, long before the first dinosaur ever took a step, the Permian extinction tore through the tree of life like a wildfire storm. It was the most devastating extinction event our planet has ever endured. Over 90% of all marine species vanished. On land, forests withered, insects disappeared, and almost all vertebrates were wiped away. It was not a moment, but a long, slow collapse. The air thickened with carbon dioxide. The oceans lost their oxygen. Volcanoes tore through the crust like wounds that could not close. What came after was not rebirth. Not yet. It was recovery, but in the slowest possible sense. Like a forest trying to regrow after being turned to ash. Like lungs relearning how to breathe. The planet entered a strange simmering silence. Life persisted, but cautiously, hesitantly, as though afraid to step too boldly back into the light. Imagine standing in the middle of Pangaea, the supercontinent that stretched almost from pole to pole. It wasn't a patchwork of vibrant green fields and snow-capped mountains, but something far more desolate. A vast, dry interior, endless plains broken by mountain ranges carved by ancient collisions. The weather was brutal. Summers scorched, winters howled, rains were rare, and when they came, they arrived in floods. The earth wasn't gentle then. It tested everything that tried to live. Still, some things did. Amid the dust and heat, a few small creatures scurried beneath ferns and broken logs. Reptiles with long limbs and cautious gaits, ancestors of lizards, turtles and crocodiles, tiny mammal-like synapsids with fur and warm blood, hugging the shadows. The plants that crept across this world were mostly spore-bearers, ferns, club mosses, and seed ferns with leathery leaves and deep roots that clawed into parched ground. There were no flowers, no grasses, no buzzing bees or fluttering butterflies. It was a world of still air and slow motion, of insects with heavy wings and silence so deep that the chirp of a distant creature would have felt like a thunderclap. In this cautious recovery, something began to stir. Evolution doesn't plan, but it persists, and over the next 10 to 20 million years the pieces began to realign. A group of animals called archosaurs, ruling reptiles, began to diversify. They were not yet dinosaurs, but they were close cousins, experimenting with posture and speed, with upright legs and nimble gaits. While many other animals sprawled low to the ground, dragging bellies across the dirt like tired thoughts, these new creatures began to lift their bodies above the earth. It was not yet dominance, but it was a difference. And sometimes, in evolution, difference is everything. By the middle of the Triassic period, the Earth was no longer just recovering. it was building again. Slowly, ecosystems re-emerged. Forests of conifers spread in long, green lines. Rivers carved channels through new stone. And across these growing worlds walked the early claimants of a future no one yet knew was coming. You might not have noticed them if you'd been there. They were not giants. They didn't roar or crash through trees. They were lean, quick, two-legged animals, perhaps no taller than your hip. Euraptor, one of the earliest known dinosaurs, was just over a metre long. Lightly built, probably agile, with a slender skull and sharp teeth. It did not dominate, but it survived. And that alone, in this strange new world, was power. These early dinosaurs did not arrive in a blaze of glory. They crept in along the edges. They shared their world with crocodile ancestors, archosaurs of a different lineage, built low and armoured, designed for ambush. And at night, in burrows or under the cover of darkness, small warm-blooded creatures, early relatives of mammals, scurried and sniffed, keeping close to the ground and hoping not to be seen. The competition was fierce, but the dinosaurs had something special. Their hips were structured to hold their legs directly beneath their bodies, rather than splayed to the side like a lizard or salamander. That gave them balance, grace, and speed. They could run farther, longer. Their lungs may have begun evolving toward the high-efficiency air sacs seen in birds today. In short, they were built for motion, and in a land where survival often meant fleeing or finding, the ability to move swiftly and steadily was a gift. As the Triassic wore on, climate shifts and minor extinction pulses continued to reshape the landscape. Rivers changed course, forests died and regrew. Each change left niches open, and when opportunity arose, these early dinosaurs moved into it. You can almost picture it. A quiet morning in a Triassic forest, mist curling low over a still wet marsh, the calls of distant reptiles echoing through needled trees, and out of the ferns steps a creature no longer quite lizard, not yet bird, light on its feet, eyes forward, breathing fast, searching for its place. That place would grow, and with it, the world would shift. By the time the first true dinosaurs stepped onto the stage of life, the world had changed again. Just slightly, but meaningfully. The forests had grown taller, the rivers had become more predictable, and the sky, though still missing wings, was beginning to fill with creatures that fluttered and buzzed with experimental grace. It was the middle of the Triassic period, about 230 million years ago. And though time had not yet written the names of its future stars, some creatures had already started rehearsing. The dinosaurs did not erupt into dominance with spectacle. They arrived softly, like new characters entering the edge of a long-running play. Small, nimble, observant. They were not the titans we often imagine. These early dinosaurs were modest in size and swift in stride, creatures built more like greyhounds than bulldozers. Herrerasaurus, one of the better-known early representatives, walked on two legs, with long claws and sharp teeth, standing perhaps waist-high to a modern adult. It wasn't the largest predator in its environment, but it was fast. And in a world of quick chances and sudden danger, speed mattered. There's a strange comfort in knowing that dinosaurs did not begin as monsters. They began as opportunists, survivors. They lived on the fringes, not yet the rulers of the ecosystem, but clever participants in a constantly changing game. Alongside them were other players, some familiar, some foreign. Early crocodilians had already appeared, though they bore little resemblance to the sluggish water-bound crocodiles of today. Many of them were upright, agile land predators, some even running on two legs. They were fast, armoured, and surprisingly adaptive. In fact, for a time, it looked like they might be the ones to dominate the planet. Meanwhile, tiny creatures with whiskers and warm blood, early relatives of mammals, lived mostly by night. These small synapsids hid from the day's heat, emerging under moonlight to forage and whisper through underbrush. Their descendants would one day give rise to elephants, whales, and others. But for now, they were barely a footnote. Mouse-sized, delicate, and deeply cautious. In this unpredictable mosaic of predators and prey, the dinosaurs had a subtle but crucial edge: posture. While many reptiles of the time sprawled sideways, dragging their bellies and swinging their limbs out to the sides like a lizard sunning itself on a rock, dinosaurs held their limbs directly beneath them. Like the pillars of a temple, their legs supported their bodies in a vertical frame, allowing for efficient movement and sustained running. This posture may not sound glamorous, but it was revolutionary. It freed them to explore new gates, chase prey more easily, and cover ground with less energy. It also meant their lungs and guts weren't compressed with every step, giving them more stamina in long pursuits. In a sense, they became Earth's first true long-distance runners, and they were fast learners. Evolution, given the right nudge, works quickly. Over the course of several million years, a blink in geological time, the dinosaur line began to split and diversify. Some adapted to eat meat, their teeth growing serrated and their claws curved for gripping and slicing. Others shifted toward plants, developing broader hips, longer necks, and beak-like jaws to crop tough vegetation. They moved into different roles: sprinters, foragers, stalkers, scavengers, and with each role came a new shape, a new form, a new experiment. The planet, still scarred from past destruction, was healing, and these strange reptiles were becoming its most promising heirs. And yet, they still weren't alone at the top. Not yet. Throughout the late Triassic, archosaurs of all types continued to flourish. Phytosaurs, which resembled crocodiles but weren't quite the same, prowled rivers and lakes. Etosaurs, armoured and herbivorous, shuffled through swamps like low-plated tanks. There were even flying reptiles, pterosaurs, flapping uncertainly through the sky on wings of stretched skin, long before birds would claim the air. The world was a layered puzzle of ancient innovation. No single group ruled completely. Not yet. But then came another shift. Toward the end of the Triassic, something, perhaps a series of massive volcanic eruptions, disrupted the planet again. The Central Atlantic Magmatic Province, a region that today spans across parts of Africa, South America and North America, erupted violently for thousands of years. Lava flowed over vast landscapes, ash filled the air, carbon dioxide surged, and the climate lurched. Species began to vanish, and as the environment buckled under the strain, many competitors of the early dinosaurs perished. Not the dinosaurs, they endured. They didn't just survive the chaos, they expanded into the spaces left behind. By the dawn of the Jurassic period, the balance of power had shifted. With many other reptilian competitors gone, the dinosaurs were free to rise. Taller, larger, more diverse than before. But that's a story for later. For now, it's worth pausing here, in this quiet moment between epochs, to reflect not on dominance, but on persistence. The first dinosaurs were not the loudest or the most dramatic. They were light-footed, flexible, efficient. They didn't crash through forests. They moved between shadows. They did not rule immediately. They waited, adapted, and endured. And isn't that often how true power begins? So if you imagine the first dinosaur, don't picture a roaring colossus. Picture instead something smaller, a creature with alert eyes and a cautious gait. Something watching the treetops sway in a warm wind, feeling the pulse of the earth beneath its feet. Waiting for the right moment, not to conquer but to belong. And that moment was coming. The dinosaurs inherited a world still piecing itself together, a planet rising from the slow ruin of extinction, reshaping itself with each pulse of volcanic breath, each tectonic shift beneath its crust. But in the age that followed their hesitant rise, Earth began to soften, just a little. The chaos of the Triassic ebbed, and the Jurassic ushered in something quieter, greener, and more intricate. It was not a gentle world, not entirely. The seasons could still swing from flood to drought. Volcanoes still whispered through the Earth's cracks in the land. But stability had begun to settle in like the calm breath after fever, and with it came opportunity. The early Jurassic was a time of rebuilding, of ecological expansion, not just in animals, but in the very bones of the land. Forests thickened. Rivers meandered in looping arcs across wide plains. Wetlands pooled beneath broad skies, and rising through it all was the great unified continent of Pangaea, still intact but already beginning to stretch, as if preparing to break apart and send its pieces drifting across the surface of the planet like slow, silent ships. This was the canvas the dinosaurs would paint with their forms, with their footsteps and nests, their tooth marks and droppings, their still-warm trails in the morning mist. And what a strange and beautiful canvas it was. There were no flowers yet, no blades of grass, no birds to call from treetops, because there were no treetops as we know them. The plant life of this world was primitive by today's standards, but elegant in its own way. The forests were made of towering conifers, cycads, ginkgos, and vast carpets of ferns. Leaves were stiff and leathery, often spiraled or feathered in shape, more like seaweed than modern greenery. Instead of sweet-smelling blooms, plants relied on wind to carry their pollen, sending invisible signals through the air in quiet, drifting threads. The colours were subdued, greens and browns with occasional yellows or dusty reds. This was not a bright jungle. It was a subdued, ancient palette, painted in the tones of moss and bark and fog. Insects buzzed through these forests, but their wings beat heavily, and their bodies were armoured like little tanks. Dragonflies the size of dinner plates, beetles with jaws like pincers, and lurking in the underbrush were early amphibians and reptiles watching, waiting, living quietly beneath the notice of the giants above. Because above them, sometimes towering far above them, were the dinosaurs. By now, the family tree of the dinosaurs had begun to grow in earnest, branching out into forms more varied than anything that had come before. Some stood 3 stories tall, their long necks sweeping through the treetops like cranes made of muscle and breath. Others crouched low, moving in herds across floodplains, their tails swaying like pendulums, their eyes watchful for predators that skulked just beyond the tree line. Everywhere they went, they shaped the land. A herd of sauropods could strip a forest in a single migration, snapping branches, trampling seedlings, stirring nutrients into the soil. Smaller herbivores moved through behind them, feeding on the leftovers, the lower foliage, the tender shoots just beginning to regrow. And after them came the carnivores, alert, efficient and hungry. But it wasn't just their appetite that left an imprint. It was their movement. The very act of walking, a simple thing, became a force of change. Their weight carved trails through soft earth. Their feet stirred up silt that fed new plants. Their dung fertilized the soil. Their nesting sites shifted the composition of entire ecosystems. Where they went, the earth remembered. And the earth itself was changing, slowly but surely. Pangaea, which had once pressed all land into a single massive continent, had begun to rift. Faults opened like quiet sighs across the crust. New seas whispered into being. Humidity increased in some regions while others dried out. All of this gave rise to more complex weather patterns, more fragmented habitats, and with that more room for evolutionary experiments. In this crucible of subtle change, the dinosaurs didn't just persist, they diversified. They filled niches like water fills cracks. Long-necked sauropods like Diplodocus and Apatosaurus roamed the open lowlands. Armoured species like Stegosaurus emerged in areas with higher predation pressures, growing bony plates and tail spikes as if the earth had whispered to them, "Be cautious." Fast, bird-hipped herbivores evolved to graze on lower vegetation, forming large herds that could flee danger as a coordinated blur of muscle and instinct. Predators adapted too. The early theropods grew smarter, faster, more precise. Their teeth evolved serrations like steak knives. Their limbs grew stronger, their eyes faced forward, for depth, for calculation, for intent. But even with all their size and strength, these creatures were not invulnerable. Life was still fragile. One storm could drown a clutch of eggs. One drought could collapse an ecosystem. One fallen tree could trap a foot and end a life. Still, the dinosaurs endured, and more than that, they flourished. There's a kind of strange poetry in imagining their presence, not as monsters, but as residents. Not as beasts to be feared, but as animals who woke up each day and did what all animals do: eat, watch, move, rest, repeat. They were shaped by their world, and in turn they shaped it back. So when you picture a dinosaur walking through its forest, tail swaying, breath rising in steam from its nostrils, don't imagine a prehistoric invader. Imagine a participant, a piece of a larger story, a creature that belonged entirely to the earth it inherited. The dinosaurs inherited a world still piecing itself together, a planet rising from the slow ruin of extinction, reshaping itself with each pulse of volcanic breath, each tectonic shift beneath its crust. But in the age that followed their hesitant rise, Earth began to soften just a little. The chaos of the Triassic ebbed, and the Jurassic ushered in something quieter, greener and more intricate. It was not a gentle world, not entirely. The seasons could still swing from flood to drought. Volcanoes still whispered through the cracks in the land. But stability had begun to settle in like the calm breath after fever, and with it came opportunity. The early Jurassic was a time of rebuilding, of ecological expansion, not just in animals, but in the very bones of the land. Forests thickened, rivers meandered in looping arcs across wide plains, wetlands pooled beneath broad skies, and rising through it all was the great unified continent of Pangaea, still intact, but already beginning to stretch, as if preparing to break apart and send its pieces drifting across the surface of the planet like slow, silent ships. This was the canvas the dinosaurs would paint with their forms, with their footsteps and nests, their tooth marks and droppings, their still warm trails in the morning mist. And what a strange and beautiful canvas it was. There were no flowers yet, no blades of grass, no birds to call from treetops, because there were no treetops as we know them. The plant life of this world was primitive by today's standards, but elegant in its own way. The forests were made of towering conifers, cycads, ginkgos, and vast carpets of ferns. Leaves were stiff and leathery, often spiraled or feathered in shape, more like seaweed than modern greenery. Instead of sweet-smelling blooms, plants relied on wind to carry their pollen, sending invisible signals through the air in quiet, drifting threads. The colours were subdued, greens and browns with occasional yellows or dusty reds. This was not a bright jungle. It was a subdued, ancient palette, painted in the tones of moss and bark and fog. Insects buzzed through these forests, but their wings beat heavily, and their bodies were armoured like little tanks. Dragonflies the size of dinner plates. Beetles with jaws like pincers. And lurking in the underbrush were early amphibians and reptiles, watching, waiting, living quietly beneath the notice of the giants above. Because above them, sometimes towering far above them, were the dinosaurs. By now, the family tree of the dinosaurs had begun to grow in earnest, branching out into forms more varied than anything that had come before. Some stood 3 stories tall, their long necks sweeping through the treetops like cranes made of muscle and breath. Others crouched low, moving in herds across floodplains, their tails swaying like pendulums, their eyes watchful for predators that skulked just beyond the tree line. Everywhere they went, they shaped the land. A herd of sauropods could strip a forest in a single migration, snapping branches, trampling seedlings, stirring nutrients into the soil. Smaller herbivores moved through behind them, feeding on the leftovers, the lower foliage, the tender shoots just beginning to regrow, and after them came the carnivores, alert, efficient, and hungry. But it wasn't just their appetite that left an imprint. It was their movement. The very act of walking, a simple thing, became a force of change. Their weight carved trails through soft earth. Their feet stirred up silt that fed new plants. Their dung fertilized the soil. Their nesting sites shifted the composition of entire ecosystems. Where they went, the earth remembered, and the earth itself was changing slowly but surely. Pangaea, which had once pressed all land into a single massive continent, had begun to rift. Faults opened like quiet sighs across the crust. New seas whispered into being. Humidity increased in some regions while others dried out. All of this gave rise to more complex weather patterns, more fragmented habitats, and with that more room for evolutionary experiments. In this crucible of subtle change, the dinosaurs didn't just persist, they diversified. They filled niches like water fills cracks. Long-necked sauropods like Diplodocus and Apatosaurus roamed the open lowlands. Armoured species like Stegosaurus emerged in areas with higher predation pressures, growing bony plates and tail spikes as if the earth had whispered to them, "Be cautious." Fast, bird-hipped herbivores evolved to graze on lower vegetation, forming large herds that could flee danger as a coordinated blur of muscle and instinct. Predators adapted too. The early theropods grew smarter, faster, more precise. Their teeth evolved serrations like steak knives. Their limbs grew stronger. Their eyes faced forward, for depth, for calculation, for intent. But even with all their size and strength, these creatures were not invulnerable. Life was still fragile. One storm could drown a clutch of eggs. One drought could collapse an ecosystem. One fallen tree could trap a foot and end a life. Still, the dinosaurs endured. And more than that, they flourished. There's a kind of strange poetry in imagining their presence. Not as monsters, but as residents. Not as beasts to be feared, but as animals who woke up each day and did what all animals do. Eat, watch, move, rest, repeat. They were shaped by their world, and in turn they shaped it back. So when you picture a dinosaur walking through its forest, tail swaying, breath rising in steam from its nostrils, don't imagine a prehistoric invader. Imagine a participant, a piece of a larger story, a creature that belonged entirely to the Earth it inherited. As the age of dinosaurs unfolded, the Earth itself seemed to become a living gallery of forms, an ever-shifting sculpture garden in which evolution shaped and reshaped creatures with a kind of unhurried wonder. Some were sleek, others armoured. Some bore plates that rose from their backs like sails catching sunlight. Others carried spikes, domes, clubs, or horns, living, defences carved in bone and sinew. It's tempting to think of dinosaurs as one thing, a unified category. But they were not a single idea. They were a vocabulary of shapes, whispered across time. If you could stand in one spot and watch the Mesozoic world turn around you, say, a riverside plain in what is now western North America, you might see an entire menagerie stroll past within a single day. A horned face moving through tall brush, a tail like a battering ram swaying in rhythm, a creature built like a barrel with legs, its back shielded by plates arranged like shingles on a roof. The diversity would not feel random, it would feel practiced, as if nature had spent ages rehearsing each form until it fit the role perfectly. At the root of all this variety lay a single ancient split, a divergence in hip structure that would, over time, lead to two great branches on the dinosaurian tree, the Saurischians and the Ornithischians. Despite their names, lizard-hipped and bird-hipped, it is the Saurischians who would eventually give rise to birds through the line of theropods. But at this point in time, it wasn't legacy that defined them, it was function. Saurischans included the long-necked massive sauropods and the sharp-toothed theropods, groups that stretched the concept of a vertebrate body to opposite extremes. The sauropods would evolve into the largest land animals ever to walk the earth, while the theropods, with their bipedal stance and clawed hands, would one day become the most agile predators of the era. But it's in the ornithischians where much of evolution's creative experimentation took place. Creatures that were often smaller, herbivorous, and uniquely armoured. These were the design puzzles, the biological oddities that now line museum halls like ancient puzzles frozen mid-solution. Consider the Stegosaurus, one of the most visually iconic dinosaurs to ever exist. It carried along its spine 2 rows of enormous upright plates, flat and roughly leaf-shaped, alternating like jagged sails in a prehistoric wind. Its tail bore long, sharp spikes, the kind of structure no predator would ignore. And yet, its brain was tiny, perhaps no bigger than a walnut. It did not need intellect. It had armour and bulk and presence. Then there's the Ankylosaurus, whose entire back and flanks were shielded in a mosaic of bony tiles, its tail ending in a club so massive it could break bones with a single swing. This was not speed. This was fortification. An animal turned into a mobile fortress. Others bore stranger features still. The Pachycephalosaurus, for instance, had a domed skull more than 20 centimetres thick. It may have used this head like a battering ram, clashing with rivals in brief, stunning contests of will, though no one is entirely certain. Evolution often writes its intentions in riddles, and paleontology is a science of patient interpretation. What's perhaps most striking is how functional each shape was despite its strangeness. These weren't mere flourishes, they were answers, evolutionary replies to specific challenges in each creature's environment. Spikes to deter predators, horns to display strength or intimidate rivals, plates perhaps for thermoregulation or species recognition, thick skulls for combat. Every structure told a story of survival, written not in paragraphs but in cartilage and calcium. And this diversity was not just physical, it extended to behaviour, to ecology, to lifestyle. Some of these dinosaurs likely lived in herds, moving in coordinated flocks across open plains. Others may have been solitary browsers, pushing through dense undergrowth alone. Some nested together in colonies. Others dug individual hollows in hidden places. We see traces of this in the fossil record, in paths preserved in hardened mud, in fossilised nests with carefully arranged eggs, in the worn patterns of teeth that suggest particular diets. This was not a world of chaos, it was a world of systems, each niche filled with a shape perfectly suited to its role. Imagine walking through such a landscape, not as a predator, not as prey, but as an observer, invisible and unnoticed. You pass beneath the shade of a cicade's grove and hear the low creaking of vegetation being chewed. A pair of small beaked dinosaurs flits past you on 2 legs, darting like deer through tall ferns. In the distance, a Stegosaurus raises its tail, sensing movement, then lowers it again. Peace returns. The air hums. Life moves in balance. There's a kind of calm in understanding that none of these creatures were monsters. They were not roaring for sport or seeking destruction. They were, like all animals, simply trying to continue, one mouthful at a time, one season after another, and that's perhaps the greatest truth hidden in their shapes. For all their bizarre appearances, for all the spikes and plates and clubs, these were creatures born of quiet necessity. Their oddities were never arbitrary. They were answers to hunger, to danger, to the need for recognition, for safety, for reproduction. Even their names, so often dramatic or terrifying, do little justice to the subtlety of their lives. Triceratops, Ankylosaurus, Parasaurolophus. The syllables roll off the tongue like spells, but they mask lives that were slow, steady, rhythmic, not unlike our own, in their own time. So the next time you see a fossil in a museum, frozen mid-roar or mid-stride, remember this: that once, long ago, this creature was not a skeleton or a curiosity. It was warm, it breathed, it moved beneath clouds that have long since blown away. It lived not in fear or glory, but in continuity. Its shape, strange as it might seem to us, was not designed to impress. It was designed to endure. It's hard to grasp, even in imagination, just how large some of the dinosaurs truly were. Not just big, but beyond the frame of daily human comparison. Larger than elephants, longer than buses, heavier than tanks. And yet they moved, slowly, deliberately, alive. It can feel absurd, almost surreal, that animals this massive once walked the same earth we now stroll with coffee cups in hand. But they did. And for tens of millions of years their footsteps marked time across plains and floodplains and fern-covered valleys. These were the sauropods, the long-necked giants who grew not simply to impressive sizes, but to impossible ones. Names like Brachiosaurus, Diplodocus, Apatosaurus and Argentinosaurus stir echoes of awe, but the animals themselves would have been more than just astonishing. They would have been strangely peaceful. Let's pause to consider one: Argentinosaurus. Based on fossil evidence, it may have reached 30 metres in length and weighed over 70 tonnes. Its neck alone could have stretched longer than a city bus, arching above trees to pluck at foliage that no other animal could reach. Yet for all its size, it was not a predator. It had no claws for grabbing, no teeth for tearing. Its skull was small, almost delicate, relative to its body, and its mouth was lined with peg-like teeth meant only for stripping leaves. These were creatures of consumption, yes, but also of rhythm. They likely moved in slow, coordinated herds, migrating with the seasons, always in search of enough food to sustain their massive frames. A single adult sauropod may have consumed hundreds of kilograms of plant matter per day. Their bellies churned with fermentation, their lungs filled with air sacs extending into their bones, lightening their enormous skeletons while providing efficient respiration. And yet, despite their enormity, there's little to suggest that they ruled with fear. Instead, they lived with a kind of quiet persistence. Predators may have circled the young or the weak, but few would have dared challenge a full-grown sauropod. Not because of aggression, but because of scale. Their size was their sanctuary. But size, of course, comes at a cost. Growing so large required incredible biological coordination. Their hearts had to pump blood vertically all the way to the brain, perhaps necessitating complex vascular systems or multi-chambered hearts. Their limbs had to be both strong and columnar, bearing weight like pillars, not like springs. Their skeletons had to balance density with mobility. Every piece of their anatomy was shaped by the simple fact that they were carrying more mass than any land animal had ever done before, or would again. And yet, they were not clumsy. Footprints left behind in fossilized mud show organized travel. Lines of tracks stretching for hundreds of meters, laid down in regular measured strides. Some show adults walking beside juveniles, suggesting herding behavior, maybe even care. The spacing of the steps suggests steady pace, not a frantic charge, but a long, slow walk. A kind of mobile stability. Try to imagine that. A clearing at dawn, the mist still, low across the grass, and through it, a procession of creatures larger than houses moving silently except for the soft tremble in the ground beneath their feet. Their breath plumes in the morning chill, their tails sway like drawn-out thoughts, and above, their long necks rise through the haze like living towers, searching the canopy for breakfast. In moments like that, size doesn't seem monstrous. It seems sacred. But why grow so large? It's a question that still echoes in paleontology labs today. The answer isn't singular. There are many reasons, and they all intertwine. Larger herbivores can digest tougher plants, their massive guts providing space and time for fermentation. They can access food sources that smaller animals cannot: high leaves, tall ferns, and branches untouched by ground-level browsers. Size also offers protection. A large body is harder to attack, harder to bring down, and in stable ecosystems, where resources are abundant and competition predictable, the pressure to stay small can diminish. Growth becomes advantage. Of course, not all sauropods were titanic. Some remained modest in size, evolving for different landscapes or food sources. But the trend toward gigantism was undeniable. In the Jurassic especially, the Earth seemed to favour the large, the slow and the long-necked. And perhaps this tells us something not just about the dinosaurs, but about their world. A world that could support such creatures was one of balance, of steady warmth, abundant plant life, and relatively few disruptions. It was a world that allowed patience. These weren't animals built for sprinting or chasing or ambush. They were designed to persist, to move steadily through time, reshaping landscapes with each step. They fertilized soil with their droppings. They opened forests with their browsing. They shaped the very face of their ecosystems, not by force, but simply by being. And when they died, as all creatures do, they left behind not just bones, but hollows in the earth that told stories. Fossil beds packed with sauropod remains suggest river crossings gone wrong, droughts that thinned herds, perhaps even migrations interrupted by sudden disaster. Their deaths, like their lives, shaped the land. In many cultures today, elephants are seen as wise, solemn, almost sacred. Perhaps if humans had shared time with sauropods, we would have felt the same. Not fear, but reverence. Not threat, but wonder. They were not kings in the sense of power, but they were monarchs of presence, living mountains with beating hearts, striding quietly across a young planet. So the next time you see a thunderstorm approaching in the distance, or hear the low rumble of something large passing behind a wall, imagine, not trucks or thunder, but a line of ancient giants moving slowly through fog. Not in search of conquest, just food, shelter, continuity. Like all things, they simply wanted to last. For all their size, their armour, their towering elegance. Not every dinosaur was a peaceful browser of treetops or a quiet wanderer of plains. The Mesozoic landscape, like all natural worlds, was shaped as much by tension as by balance, by the swift as well as the slow. Alongside the herds and the giants, there moved creatures built for speed, precision and force, predators whose bodies were sharpened by necessity. These were the theropods, the bipedal, often carnivorous dinosaurs whose lineage would one day take flight, but who first stalked, chased, and struck with deadly efficiency. Their forms were lean and dynamic, their bones hollow but strong, their skulls narrow and packed with sensory power. They were not always the biggest, but they were rarely unprepared. You probably know some of them by name. Allosaurus, with its three-fingered hands and double-crested brow. Tyrannosaurus rex, whose massive skull and bone-crushing bite made it one of the most formidable land predators in Earth's history. Velociraptor, smaller than Hollywood might suggest, but far more interesting. Lightweight, agile, and probably feathered. Let's begin with Allosaurus, a predator that roamed the late Jurassic and may have hunted in groups. Its teeth were curved and serrated, perfect for slicing through muscle and tendon. Its arms, though short compared to its body, ended in claws that could grasp and hold. It may have ambushed sauropods or scavenged carcasses depending on opportunity. We'll never know exactly how it hunted, but the signs it left behind, marks on bones, teeth embedded in fossilized flesh, hint at a life of pursuit and contest. Then there's T-Rex, the most iconic carnivore in the fossil record. Despite being mocked for its small forearms, T-Rex was no joke. Its jaw muscles were among the strongest ever measured. Its teeth weren't just sharp, they were thick, banana-shaped tools designed not to slice delicately, but to shatter bone. Fossilized prey bones show signs of healing after T-Rex bites, suggesting it attacked living animals. It could smell from kilometers away. It had binocular vision, and while its top speed remains debated, it didn't need to sprint to be successful. It just had to be there, massive, aware, relentless. But perhaps more remarkable than claws or teeth is what these theropods began to carry with them. Feathers. Yes, feathers. The evidence began trickling in the late 20th century, but by now it is undeniable. Fossils from China, meticulously preserved in fine volcanic ash, show small theropods covered in primitive feathers. Downy filaments at first, like fuzz on a peach. Later, more complex structures, branched, patterned, functional. It was a revelation. These were not birds, not yet, but they were on the way. Velociraptor, once imagined as a scaly, snake-eyed killer, was likely feathered, at least in part. So were Microraptor, Sinosauropteryx, Dazzling, and others. The presence of feathers wasn't limited to one branch of theropods. It appeared in multiple lineages, which means feathers themselves may be ancient, far older than flight. Why grow feathers if not to fly? The answers lie, as they often do, in context. Feathers likely began as insulation, fine body coverings to retain heat in small active animals. Some modern birds still fluff their feathers when cold. Later, feathers may have played a role in display, attracting mates, signalling dominance, intimidating rivals. Their colours and patterns would have told stories we can no longer read, but whose echoes remain in chemical traces locked in fossilised melanosomes. Flight came later. Evolution rarely creates something for a single purpose. A structure that begins in warmth becomes beauty, then function, then escape. Feathers transformed stage by stage from fluff to lift, from heat to flight. But in the time of theropods they were still grounded, and in that grounded state they were deadly. Imagine a predator like Dromaeosaurus, a close relative of Velociraptor, with feathers along its arms and tail, a sickle-shaped claw on each foot, and the agility of a hawk. It didn't need to be large, it needed to be fast, to cut, to disappear again, like wind in tall grass. Not all theropods were hunters, some were omnivorous, even herbivorous. Creatures like Therizinosaurus, with its bizarre potbelly, long neck and metre-long claws, suggest a diet of plants, fruits and perhaps small animals. Its claws may have been used for defence or for reaching vegetation, or perhaps even for stripping bark. It's a creature that defies neat categorisation, as if evolution said, "Let's try something odd," and nature replied, "Why not?" This variety reminds us that teeth and claws do not always mean violence. They mean adaptation, to niche, to need, to the shape of life in a world that required creativity just to survive. And behind all of this, behind the snarling jaws, the feathers, the claws, was a brain. Theropods were, in many cases, among the most intelligent dinosaurs. Their brain-to-body ratios were higher than those of most sauropods or ornithischians. They had keen eyesight, strong memory, complex coordination. They could learn. They could adapt. Some may have hunted in coordinated groups, though that remained speculative. And one lineage, small and feathered and clever, would survive when all the others fell. It's difficult to look at a robin today. Chest puffed out, head cocked, feathers fluffed against the wind, and see in it a predator. But the bones tell the story. The wishbone, the hollow skeleton, the 3 forward toes, the feathers, the posture, the lungs. Every bird is a theropod in a quieter skin. Every beak is a memory of jaws that once bit harder. And every egg, nestled warm in a modern nest, is a whisper from the past. A shape unchanged, a continuity of care, a fragile promise carried through fire and time. It's tempting to think of dinosaurs in terms of spectacle. Colossal battles, piercing roars, teeth locked in combat. But for every moment of conflict preserved in imagination, there were thousands more that were quiet. Dinosaurs did not spend most of their lives fighting. They spent their time eating, wandering, resting, watching, and raising their young. They lived in cycles, in seasons, in rhythms as ancient as the dust that still holds their bones. To understand them fully, we must look not only at how they hunted or ran, but how they nested, how they hatched, how they raised the next generation, and, in time, how they died. Across the fossilised riverbeds and eroded cliffs of the world, paleontologists have uncovered evidence of not just individual dinosaurs, but family groups. There are trackways with smaller footprints beside larger ones, suggesting juveniles walking in step with adults. There are fossil beds where entire groups died together, their bones tangled in postures of collapse and closeness. And perhaps most strikingly, there are nests, circular depressions in ancient sediment, carefully arranged, with eggs still held in their cradles of stone. Some of the most famous nesting fossils come from a dinosaur known as Maiasaura, whose name means good mother lizard. In Montana, entire colonies of their nests have been found, clustered close together like a prehistoric village. Within those nests are not just eggs but tiny skeletons of hatchlings, some with developing teeth and partially formed bones, suggesting they stayed in the nest after hatching. This implies care, parental feeding, protection, warmth. It's a portrait of life not as solitary but as social. Even the fearsome velociraptor may have nested in coordinated spaces, and species like Oviraptor, once mislabeled as egg thieves, have been found fossilised atop nests in brooding posture, wings spread as if to shelter their clutch from wind or rain. The name, egg thief, lingers unfairly. The reality is more tender. These were animals that guarded their unborn. Of course, not all dinosaurs raised their young. Some may have laid eggs and moved on, letting heat and chance do the rest. But the variety of strategies only adds depth to the picture. Some species hatched precocial young, ready to walk and follow. Others produced altricial hatchlings, helpless at first, dependent, needing guidance. It is a reminder that even in deep time, the boundary between instinct and care was not so sharply drawn. And so we begin to see them differently. Not just as shapes, but as stories, as creatures with moments of gentleness. A long-necked sauropod laying her eggs in soft soil, then covering them with foliage before walking on. A pair of hadrosaurs nudging their young into deeper grass to hide them from view. A lone ceratopsian standing watch as dusk approaches, horn lowered in wary silence. These scenes may never fossilise fully, but their echoes remain, in the positioning of bones, in the depth of nests, in the way some juveniles show growth lines in their bones, suggesting periods of fast development under favourable care. And eventually, as with all things, there was death. The fossil record is a cemetery written in layers, a slow archive of endings. But even in death there is story, there is structure, there is pattern. Some skeletons are found in curled postures, heads thrown back, tails arched, a sign of dehydration or suffocation, perhaps during drought or volcanic ashfall. Others are discovered in groups, preserved by sudden floods, their lives stopped mid-migration. Some are solitary, laid down gently in riverbeds or beneath fallen trees, the quiet exit of an old animal who had nothing more to run from. It's tempting to project meaning into these scenes, to imagine grief, memory, farewell. We cannot know what these creatures felt, if they mourned, if they paused in sorrow. But we do know that they lived long enough to grow old, that some show signs of healed fractures, that many carried diseases, that some bore the marks of old wounds. These were not brief lives. Some sauropods may have lived 70 or more years. Predators bore the wear and tear of long use. Broken teeth, arthritic joints, bone infections. They endured, and when they fell, their bodies became part of the land once more, scavenged, weathered, buried, fossilised, transformed. There's something profoundly gentle in that idea. that a creature who once walked under strange stars is now a piece of mountain or cliff or museum shelf, that bones which once supported breath now support memory. And perhaps it's in these remnants, not just of anatomy, but of behaviour, that we can find the deepest resonance. Because what matters in the end is not how long they ruled or how fearsome they were, but how thoroughly they filled their world. They didn't just survive, they inhabited. They nested in the warm mud. They travelled in groups. They protected what they could. They lived, not as symbols or monsters, but as participants in a long, patient dance of existence. And that is where we'll leave them for now. In nests tucked beneath ferns, in footprints stretching across dry lake beds, in the hush between heartbeat and silence, alive once, and remembered still. By the time the Cretaceous period unfolded, some 145 million years ago, the world had already borne witness to creatures of impossible size and staggering variety. But something quieter, smaller, and altogether more transformative was beginning to rise from the soil. Not with a roar, but with a blossom. It began, as many revolutions do, in soft, almost unnoticed ways. A bud here, a delicate petal there, an adaptation so subtle that for a time it left no fossils, no footprints, no drama in stone. But slowly, surely, Earth was changing. Not because of a new predator or a shifting sea, but because of a new kind of plant. The flowering plants had arrived. Before this, the world was ruled by green giants of a different kind, conifers, cycads, ginkgos, ferns that had outlived cataclysms and spread their spores on the wind like dust from old parchment. These plants were sturdy, well adapted, but limited in their design. They grew slowly, reproduced without colour, and required vast patience from the ecosystems they anchored. The angiosperms, flowering plants, were different. They were not content to wait for wind or time. They seduced. They recruited. They coloured the world. With flowers came petals. With petals came scent. With scent came strategies. These plants used a lure to reproduce. Their pollen wasn't simply released into the breeze, it was placed, delivered, carried by partners, many-legged, humming, burrowing, buzzing. They formed alliances with insects, entered into deals with bees and beetles, and in doing so, rewrote the rules of survival. And as the plants evolved, so too did the animals around them. Among the dinosaurs, the rise of flowering plants brought with it a quiet revolution in the mouth. Herbivores had long fed on tough leaves and fibrous conifer needles, but the softer, more nutritious vegetation of the angiosperms allowed, and demanded, more sophisticated tools for chewing. Enter the hadrosaurs, sometimes called duck-billed dinosaurs. They were among the most advanced plant eaters of their time. Behind those broad, seemingly gentle mouths lay one of the most complex dental systems nature had ever devised. Some hadrosaurs had hundreds of tightly packed teeth arranged in stacked rows, creating a grinding surface like a natural millstone. As older teeth wore down, new ones grew in beneath them, forming a continuous conveyor belt of replacement. They didn't just bite, they processed. They chewed in patterns. They sheared and mashed, breaking down leaves and twigs with movements that seemed remarkably mammalian. Their skulls were not only equipped for chewing, but for sensing. Many species had expanded nasal passages and crests that may have enhanced vocalization or smell. Picture a Corythosaurus moving through a blooming meadow, head swaying, mouth working rhythmically as it clipped fresh angiosperm leaves. Around it, insects hum. The air smells faintly of resin and damp soil. The flowers open as the sun rises. This is not a Jurassic forest. This is something new, and with this newness came complexity. Because flowering plants didn't just feed, they changed the timing of a life. They bloomed in cycles, linked to seasons and light. They responded to pollinators and weather in more precise rhythms. In turn, animals that fed on them both insect and reptile, began to live not only by instinct, but by calendar. Migration patterns shifted, nesting seasons synced, behaviours evolved in tandem with petals and pollen. What started as a change in plants became a change in time, and beyond function, there was form. The world began to look different. Where once there had been endless green broken only by shadow, there were now bursts of colour, pinks, whites, blues, and yellows scattered across forest floors. Insect crawled into these pockets of pigment, carrying dustings of genetic promise from one bloom to another. It was no longer just survival, it was symphony. Even the air began to change. Pollens with new shapes, scents that lingered, nectar, rich and inviting. Ecosystems grew not only more connected, but more expressive. This was a world that didn't just work, it communicated. And in this transformation, dinosaurs, those creatures so often cast in the harsh tones of scale and claw, were not left behind. They adapted. They participated. Some of the smaller herbivorous species developed beaks better suited to plucking delicate foliage. Others shifted diets seasonally, following blooms as they ripened. Still others, like the hadrosaurs, evolved vocalizations and social structures that may have echoed the changing complexity of their surroundings. There is even the possibility, though still debated, that the rise of flowering plants and the dietary richness they offered allowed certain species to grow faster, mature earlier, or live in more varied habitats than before. The land was no longer a singular canvas of green, it was a mosaic, and the dinosaurs were woven through it. So much of this story is told not through grand fossils but through small traces, impressions of leaves, fossilized pollen grains, tiny fossilized flowers, and the chemical fingerprints of nectar long since dried. It is a puzzle of patience. But when assembled, it tells a story not of conquest or catastrophe, but of emergence. It tells of a world where beauty began to matter, where colour and shape and scent were not luxuries but strategies, where survival was no longer only about muscle and bone, but about nuance, about fit, about timing. It's easy to forget when looking at a dinosaur skeleton posed dramatically under a museum dome, that these animals lived in ecosystems far more complex and vibrant than stone suggests. They walked through fields of blossoms. They grazed beneath flowering trees. They may have brushed past petals, stirred swarms of beetles with each step, or paused to sniff something sweet on the air. The world was not yet ours, but it was becoming more like it, and it all began with a bloom. If you close your eyes and imagine the Cretaceous world at its height, you might first picture the dinosaurs, massive, lumbering, regal. But if you listened instead, tuned your senses not to the thunder of footsteps but to the subtler textures of life, you'd hear something else. A chorus, not of roars but of wings, of chitin rubbing against chitin, of gentle buzzing woven into leaf rustle and wind. This was the age of colour and hum. A world where insects were no longer just background detail but central players in a grand ecological experiment. Their wings beat in rhythm with the blooming of flowers. Their legs carried not just pollen, but the future of entire forests. Their compound eyes began to see more than shapes. They saw messages, ultraviolet signals written into petals, patterns etched in pigment, a visual dialogue between plant and pollinator. Before the Cretaceous, insects were already present, of course. Dragonflies had skimmed the swamps of the Carboniferous. Beetles had crawled beneath Jurassic ferns. But it was in this flowering world that insects truly flourished, not just in number, but in role. They became agents of reproduction, couriers of genetic material, matchmakers between species rooted in place. In response, flowers began to compete, not in height or toughness, but in appearance. They evolved colours that dazzled, shapes that beckoned, scents that lingered, nectar that offered sweetness in exchange for service. What emerged was not simply pollination, it was partnership. And in this mutual embrace, the landscape transformed. Hovering through that transformed world were creatures like early bees, their bodies dusted in golden pollen, navigating by the geometry of sunlight. Moths with delicate wings spiraled through twilight, drawn to pale blossoms that opened only at dusk. Beetles crawled between petals, rough and clumsy, but effective in their task. Flies, often overlooked, carried tiny flecks of life from bloom to bloom, each landing an act of quiet continuity. We don't have fossils of songs, but we know that wings make sound, and in that Cretaceous dawn, the forest would have buzzed, not constantly, not loudly, but richly. The air alive with the mechanical whispers of 10,000 wings, and the dinosaurs, ever responsive to their environments, were part of this story too. In a world increasingly saturated with colour and movement, visual signalling took on new importance, not just for plants and insects, but for vertebrates as well. Dinosaurs, once imagined as drab or uniform, may have been far more vibrant than we once believed. We now know that some small feathered dinosaurs, thanks to pigment cells preserved in fossilised feathers, bore patterns, stripes, iridescence, contrasting hues. Anchiornis, for instance, a small theropod with wings, had black and white feathers and a reddish crest. Sinosauropteryx likely had a striped tail and ruddy tones along its back. These weren't just splashes of colour, they were signals to mates, to rivals, to predators. Colour, in this new world, was a form of communication, and it may not have stopped with the small ones. Larger dinosaurs may have borne skin patterns, stripes, spots, patches, for camouflage, display, or thermal regulation. Some ceratopsians had elaborate frills, possibly adorned with colourful keratin or soft tissue. Hadrosaurs had crests that may have supported brightly coloured sacs, used for courtship displays or species recognition. We can't be sure of every shade, of course. Fossilization is a selective memory. But the presence of structures that suggest display, combined with the ecological pressure of a blooming, buzzing world, makes it likely that the Cretaceous was far more vivid than the stone-grey reconstructions of old textbooks would suggest. It was not just a world of green and brown. It was a mosaic, petal pink and fern green, beetle black and feather red. A world not simply alive but expressive. And all of this, the flowers, the insects, the feathers, the eyes attuned to subtle hues, was part of a growing complexity that defined the late Mesozoic. Life was not just growing larger or faster, it was growing more specific. Interactions became more intricate. Some plants evolved to bloom only at certain times of day, targeting specific pollinators. Some insects developed tongues or mouth parts shaped precisely to the flowers they visited. Certain dinosaurs may have followed specific food trails, depending on what was in bloom, or used environmental cues shaped by plant cycles to time their migrations or mating behaviours. Ecology, once a simple web, had become an orchestra. Dozens of species playing coordinated notes, rising and falling with the sun, the season, the shape of a leaf. And though this richness is easy to overlook when we focus only on teeth and claws, it is what made the world livable, sustainable, beautiful. Insects sang, flowers opened, dinosaurs watched, and the earth hummed with a kind of layered music, a harmony of colour and motion and breath. It may be hard to imagine that in a world of titans it was the smallest creatures that began to write the new rules. But that's how change often begins. Not in thunder, but in flutter. Not in jaws, but in pollen. Not in force, but in invitation. And in the end, it may have been these delicate interactions, these unassuming alliances that shaped the world we inherited. Because when the age of dinosaurs came to a close, it was not the roar of giants that endured. It was the buzz of bees, the flutter of wings, the whisper of wind through blooming branches, a melody that had only just begun. In the story of life, The leap from earth to air is one of its most astonishing chapters. Not because it happened all at once, but because it happened so gradually, so delicately, that even now it feels like a kind of magic. A whisper of motion, a soft lift, a glide across ancient light. Long before hummingbirds hovered over flowers or swans sliced through morning mist, there were creatures learning the language of the sky, not through instinct, but through anatomy. They were not quite dinosaurs anymore, but not yet birds. They were the in-between, the twilight forms, the ancestors of air. We begin, perhaps most famously, with Archaeopteryx, a name that echoes across textbooks and museum plaques like the first word in a new dialect. Discovered in 1861, just 2 years after Darwin published On the Origin of Species, this fossil became a quiet revolution in stone. Delicate feathers traced in limestone, wings spread. But look closer, and the story becomes more complex. Because Archaeopteryx is not a bird in the way we know birds. It had teeth, a long bony tail, 3 clawed fingers on each wing, no keeled breastbone for flight muscle attachment. It looked like it wanted to fly, but hadn't quite decided how. Its feathers were asymmetrical, suggesting some capacity for flight or gliding, but its skeleton still carried the echoes of its terrestrial past. It was, quite literally, caught in transition. And it wasn't alone. Creatures like Microraptor, unearthed from the fine sediments of Liaoning, China, expanded the possibilities even further. Here was a dinosaur, small, feathered, elegant, that seemed to carry not 2 wings but 4. Its hind legs bore long feathers, forming a second pair of airfoils. Its body was light, its limbs flexible. Whether it glided from tree to tree or beat its wings in short bursts remains debated, but one thing is clear. This was not a ground-bound predator. It was something else. It's important to understand that feathers did not evolve for flight. That came later. The earliest feathers were simple filaments, fine, hair-like structures likely used for insulation, for warmth, not wind. As they grew more complex, branching, flattening, overlapping, they became tools for display, for recognition, for warning, for beauty. A crest of bright feathers might signal strength. A flash of colour might deter a rival. A soft fluff might keep a hatchling warm through a chilly night. Only after these functions had matured, only after feathers had become established across body plans and lifeways, did some of them begin to catch air. Flight, in other words, was not the goal. It was the side effect, and that's what makes it so remarkable. Because once feathers began to interact with wind, evolution listened. It modified bones, hollowing them, lightening them. It reshaped arms into wings. It fused fingers, elongated forelimbs, changed shoulder joints, rearranged muscle groups. The entire architecture of the body shifted to support this newfound partnership with the sky. From these experiments came early flyers, some gliders, some flappers, some something in between. The trees of the late Jurassic and early Cretaceous must have shimmered with movement, feathers glinting in the dappled light, small bodies leaping, flaring, breaking, spinning. These were not birds as we know them, but they were something no less extraordinary. Flight under construction. And what a place to construct it! The Mesozoic forests, dense with cycads, conifers and early flowering plants, offered a vertical world rich in niches. There were insects to catch, fruits to pick, perches to seek, and for small theropods navigating this layered terrain, the ability to glide or flutter was not a luxury. It was a solution, a survival strategy, a way to descend safely, to escape predators, to move between food sources with agility. In this environment, wings made sense. Not perfect wings, not yet, but wings that worked well enough to be used and refined. Consider the shoulder joint, a marvel of evolutionary remodelling. To fly, an animal must lift its wing above the spine, a motion most reptiles cannot perform. Early flying dinosaurs modified their shoulder girdle, eventually developing a structure called the furcula, the wishbone, which acted like a spring storing energy during wing beats. Their sternums, once flat, began to keel outward, providing an anchor for flight muscles. Their tails shortened, forming a pygostyle to support tail feathers that acted like rudders. Their hands fused into aerodynamic surfaces. Their heads shrank. Their balance shifted. They became flight itself. But again, not in one moment. It is tempting to draw a clean line between dinosaurs and birds, to place Archaeopteryx on one side and a robin on the other. But the truth is far softer, more blended. There is no clear edge. There is only movement, adjustment, subtle transformation. Even today, some birds echo their ancient past. The Hoatzin of South America, for example, hatches with claws on its wings, claws it uses to climb before it can fly. Ostriches and emus, though flightless, bear powerful legs and feathers for display. The modern chicken carries genes that, if reactivated, can produce dinosaur-like traits in the embryo. The past is not past. It is folded into the present. So the next time you watch a sparrow flip between fence posts, or a pigeon lift awkwardly from a sidewalk, or a hawk wheel above an empty road, consider what you're seeing. Not just a bird, but a survivor, a descendant, a memory given muscle and wing. They were never meant to fly, and yet they do, with grace, with power, with every beat of those borrowed bones. If you were to sit quietly by a park bench, near a patch of grass and a few scattered crumbs of bread, you might witness a pigeon land in front of you. Head bobbing, feet splaying, feathers slightly puffed against the morning air. It may seem unremarkable, ordinary, something so common that you barely notice it. And yet, in that simple creature, so familiar it disappears into the background, you're looking at the living echo of a world long vanished. Because birds are not just modern animals, they are dinosaurs. Not metaphorically, not symbolically, but literally. A pigeon on a sidewalk and a velociraptor in a forest 70 million years ago are part of the same family tree, connected by muscle, bone, and breath. What makes a bird is not simply feathers or flight. It is a suite of adaptations so deeply woven into their being that every part of their body seems designed with purpose, precision, honed by time. Let's begin with the skeleton. Bird bones are unlike those of mammals. They are pneumatized, filled with air spaces that connect to the respiratory system. This reduces weight without sacrificing strength. Their skulls are lightweight, their limbs elongated and fused in ways that streamline their entire form. Many bones are joined to create rigid frameworks, particularly in the thorax and pelvis, allowing for efficient flight mechanics. Their arms, now wings, have lost claws in most modern species, fused into a structure of 3 fingers. Their tails have shrunk to a stub of fused vertebrae, the pygostyle, which supports the fan of tail feathers used for balance and steering in flight. Their breastbone or sternum is deeply keeled in flying birds, providing a large surface for the powerful pectoral muscles that drive the wings. But bones are just the beginning. The real marvel lies in the respiratory system. Birds breathe unlike any other vertebrates. While mammals inhale and exhale from the same set of lungs, birds use a system of air sacs that allow air to flow in one direction through the lungs. This ensures that oxygen-rich air is always passing over the gas exchange surfaces, even during exhalation. It is astonishingly efficient. This means that birds can extract more oxygen with each breath, allowing for sustained energy output, whether in flight, on the run, or in high-altitude conditions where the air is thin. Their hearts, too, are large relative to body size, muscular engines that keep pace with their demanding metabolisms. Their blood carries oxygen rapidly, their muscles burn energy at high speed, and their digestion is streamlined to extract nutrients quickly and effectively. It's easy to see how these features serve a bird in flight, but what's often overlooked is how much of this evolved before birds ever took to the sky. Many of these respiratory and skeletal features first appeared in small feathered theropods. Velociraptor, for example, had a furcula, wishbone, air-filled bones, and likely a bird-like lung system. It also had feathers, not just for insulation or display, but with the asymmetric veins that suggest aerodynamic function. And here's the quiet truth that so often goes unnoticed. Birds didn't replace dinosaurs. They are dinosaurs. They are the last branch, the final survivors of a great lineage that once shook the ground with every step. They carry that legacy not as burden, but as birthright. That robin outside your window, a theropod. The sparrow perched on the power line, a distant cousin of T-Rex. The hen in a coop clucking softly as the sun rises. A modern echo of ancient clawed predators. It can be jarring to think of it this way. We're used to dividing the world into before and after, into what is gone and what remains. But evolution does not work in sharp lines. It works in gradients, in soft transitions, in long, winding branches. Birds are not fossils. They are the future of a past that never truly ended. And the more we've studied them through genetics, morphology, behaviour, the clearer the picture becomes. Their skulls follow similar developmental patterns. Their limbs develop in the same embryonic stages. Their proteins match. Their eggshell structures align. Their nesting behaviour reflects instincts once fossilised in stone. Even their eyes, keen, sensitive to movement and colour, reflect the evolutionary pressures of theropod hunters who needed to track prey across dynamic, shifting landscapes. You're surrounded by dinosaurs every day. They visit feeders. They build nests beneath eaves. They wake you up at dawn and follow ships at sea. They peck at your sandwich crust. They perform aerial displays in rural skies. And they live in every corner of the world, from icy tundra to burning desert. They've become small. Some have lost flight. Some singing, some swim. But they remain. And in their presence, there is a comfort, a continuity. It means the story didn't end, not entirely. The great extinction that erased the Triceratops and the mighty Tyrannosaur did not wipe the slate clean. It left behind a feathered thread, and that thread was enough. Evolution took hold of it, rewove it, let it branch and sing and soar. So the next time you see a gull riding the wind above a highway, or hear the chirp of a bird at dusk, don't think of it as something separate from deep time. Think of it as an invitation to look again, to listen. Because in the language of wings and beaks, of feathers and hollow bones, the ancient world is still speaking. And it does so in every flutter, every call, every lift of air. It's easy to picture dinosaurs as cold-blooded colossi, slow, scaled, basking under ancient suns like oversized reptiles from another age. After all, for most of the 20th century, that's how they were drawn. Giant lizards, living fossils, creatures ruled not by speed or heat, but by inertia. But time, like science, changes everything. Because now we know, many dinosaurs weren't sluggish, cold-blooded beasts. They were warm-blooded, active, alert. They breathed deeply, ran swiftly, grew fast. They burned energy like furnaces in motion. They were hot, biologically, not metaphorically, and their world pulsed with a higher tempo than we ever imagined. Warm-bloodedness, or endothermy, is not just about having a warm body. It's a whole physiological strategy. It means generating internal heat through metabolism. It means maintaining a stable temperature regardless of the surrounding environment. And it opens doors to faster movement, sharper reactions, more complex behaviours, and the ability to inhabit places that swing between cold and warm. It is an energy-expensive way to live, but it gives an edge. And the evidence that many dinosaurs shared this trait is increasingly clear. Start with their growth rates. Fossilized bones can be read like tree rings. In cold-blooded animals, growth slows in colder seasons, leaving visible pauses, dense, dark bands. But in many dinosaurs, growth was more continuous, more rapid, more like birds and mammals than lizards or turtles. Some species reached adult size in less than a decade, an astonishing feat for creatures weighing several tons. That kind of rapid development requires constant food intake and a metabolism that never really powers down. It suggests heat inside. Then there's the structure of their bones. When viewed under a microscope, the bones of warm-blooded animals look different. They contain a woven matrix filled with tiny blood vessels, supporting quick remodeling and oxygen delivery. This pattern, called fibrolamellar bone, is common in mammals, birds, and many dinosaurs. It means their skeletons were dynamic, growing, adjusting, healing. Not rigid like stone, but alive, actively maintained. Add to that the presence of feathers, not only for flight or display, but also for insulation. Feathers trap heat. They form a barrier against the cold. The simplest filaments, like proto-down, would have been especially good at wrapping small bodies in warmth. Many small theropods were covered in them. Some larger dinosaurs may have had them in patches. This is not the attire of a sun-dependent ectotherm. It is the wardrobe of something burning heat from within. And don't forget the lungs, or at least the clues we have about them. Certain theropod skeletons show traits consistent with a bird-like respiratory system. Ribs and vertebrae structured to support air sacs, long necks that require efficient breathing, deep chests for muscular movement. Air sacs don't just allow better oxygen exchange, they also help regulate body temperature by moving large volumes of air through the body. In birds, this system is key to flight. In dinosaurs, it may have been key to stamina, a way to fuel long-distance walking, rapid bursts of speed, and high-energy lifestyles. So, what does all this mean? It means dinosaurs were not reptiles that ruled by size alone. They were metabolically alive, living at high speeds with warm blood pumping fast beneath skin and scale and feather. Their world was not slow, it was vital. Think of a young Troodon, perhaps. Small, bright-eyed, lithe. It wakes before dawn, feathers fluffed to trap warmth. Its heart beats quickly. Its vision sharpens in the dim light. It moves with purpose, not sluggishly, but swiftly, searching, listening, learning. Or picture a mother Maiasaura, resting in the shadow of conifers, wrapped in early morning mist. Her body radiates warmth. Beneath her, eggs pulse with life, heated not by the sun but by her own metabolism. She guards them not with detachment, but with care. She waits, she endures the chill. This is not a reptilian scene. This is the world of warm-bloodedness, of inner fire. And in evolutionary terms, it changed everything. Endothermy allowed dinosaurs to explore ecological niches that cold-blooded animals couldn't reach. They could survive in cooler climates, move at dusk or dawn, maintain activity in rain or cold wind. They could hunt with precision and speed. They could migrate, defend, nurture. They could live faster and longer than most of their competitors. It also meant that when they grew feathers, they already had a reason to keep them. Long before flight, feathers helped with thermoregulation. They kept warmth close. Later, they took on other roles: display, camouflage, aerodynamic control. But their first job, most likely, was to keep the fire in. This shift, from ectothermy to endothermy, was not sudden. It did not happen in a single species or in a single step. It likely evolved gradually, in parallel with changes to heart structure, blood flow, lung design, and brain size. But over time, it became defining, and perhaps most striking of all, it aligned with behaviour. Warm-blooded animals tend to be more active, more social, more attentive to their young. And in dinosaurs we see this too. Nesting behaviour, evidence of parental care, group movement, vocal communication, a kind of ecological sophistication that feels remarkably modern. Of course, not all dinosaurs were the same. Some large sauropods may have used mass and shape to retain heat passively. much like whales or elephants. Others may have had lower metabolic rates, but the trend, especially among theropods and smaller herbivores, was toward higher activity, higher energy, and yes, warmth. So perhaps it's time to revise that ancient image. Forget the cold-blooded behemoth sunbathing on a rock. Picture instead a sleek, alert creature moving through ferns and flowering shrubs, body humming with heat, muscles coiled, eyes sharp. A creature not of slowness, but of tempo. A warm-blooded animal in a warm-blooded world. One that didn't just live in the Mesozoic, but that shaped it. There are endings that arrive slowly, like dusk spreading across a wide horizon. And then there are endings that fall from the sky. 66 million years ago, the world was full of life. The air buzzed with insects, forests rustled under the weight of hadrosaurs and ankylosaurs, and in the warm shallows of inland seas, plesiosaurs drifted beneath the sun. The sky itself was home to pterosaurs gliding in silence, while birds, a growing lineage, fluttered through trees rich with new blooming flowers, and somewhere far above, in a darkness that no creature had ever seen, a rock hurtled toward Earth. It was small, in cosmic terms, barely 10 kilometers across, but it travelled with the force of a god's whisper turned into thunder, a velocity so fast it would cross the sky in seconds. No creature saw it coming, and none had the language to understand its meaning. If you could stand still and watch it, you might first notice a shimmer, a star that seemed to grow brighter, then too bright. Then it would vanish behind the curve of the Earth, silent, invisible, and in that moment before impact, there would be only stillness, a breath caught in time. Then, everything changed. The asteroid struck the Earth near what is now the Yucatan Peninsula in Mexico. It hit shallow sea, and in less than a second, it unleashed more energy than all the nuclear weapons humanity has ever built. Combined, the sea vaporized, the crust shattered. A crater, 150 kilometers wide, opened in a flash of violence no eye would live to see. Shockwaves tore through stone and sea alike. Winds faster than hurricanes spread outward in concentric rings. Fires kindled spontaneously across forests thousands of kilometers away as molten rock rained down from the sky. Tsunamis hundreds of meters high surged through inland seas, sweeping sediment and bones and life into swirling ruin. But it wasn't the impact alone that ended an era. It was the sky that followed. The force of the collision sent vaporized rock and sulfur into the upper atmosphere. This fine dust spread across the planet, carried by wind mixing with soot from global wildfires. The sky, once blue and open, turned grey, then brown, then black. A darkness settled, thick and persistent, like a curtain drawn over a stage that would never rise again. Photosynthesis halted. The flowers that had opened each morning no longer bloomed. Trees stopped growing, ferns wilted, the insects that depended on nectar vanished, and the herbivores, great herds of Triceratops, long-necked Alamosaurus, the many duck-billed hadrosaurs, found nothing to eat. Without them, the predators followed. Tyrannosaurus rex, that titan of muscle and vision and jaw, found fewer and fewer meals, fewer trails to follow. More silence. Temperatures dropped. The ashen particles in the sky reflected sunlight, turning day into a dim twilight. In some places it may have stayed that way for months. A nuclear winter long before humans ever invented war. Global temperatures plunged, rain fell less often, ecosystems collapsed from the bottom up, and the world became quiet. It's a kind of silence that isn't just the absence of sound, but the absence of rhythm, the absence of routine. No morning bird song, no midday chirr of insects, no rustle of foraging feet or crackle of leaves under claw. Just stillness stretching over continents. Fossil records show us what came next, not in moments, but in percentages. roughly 75% of all species on Earth vanished. Not instantly, but inevitably. The large, specialised creatures were the first to go. Animals that needed large amounts of food, that couldn't adapt diets quickly, or whose life cycles were too slow to adjust. They faded like echoes. Among them were the non-avian dinosaurs. They had ruled the Earth for over 160 million years. They had filled every niche, from towering sauropods to swift raptors, armoured tanks to crested singers. But they were part of a world that depended on stability, on sunlight, on plants that grew, seasons that cycled, prey that multiplied. And without those threads, the great tapestry unravelled. It's tempting to imagine a final moment, a last dinosaur standing alone in a forest turned ghostly grey, breathing shallow breaths, tail twitching at fading scents. But extinction rarely offers such clarity. The end is diffuse, scattered. Some died in floods, some starved, some froze, some never hatched. What unites them is the silence that followed. A world without dinosaurs. For the first time in over 100 million years, the Earth belonged to smaller things. When the fires dimmed and the skies finally began to clear, months, perhaps years later, what remained was a world quieter than anything that had come before it. The great thunder of dinosaur herds, the echoing cries of predators, the wing beats of pterosaurs high above the treetops, gone. All that sound, all that movement had unravelled into stillness. But extinction, even on a scale this vast, is never absolute. Life has a way of slipping through the cracks, not always the grand or the powerful, but the small, the quick, the hidden. Those who endured the long night of the impact did not do so through strength, but through circumstance and luck, and traits that, in the age of giants, might have seemed unremarkable. Among the survivors were the mammals, small, shrew-like creatures, most of them nocturnal, warm-blooded and quick. They could dig, they could hide, they could eat almost anything, seeds, insects, roots. When the forest burned and the flowers faded, they retreated into crevices, into burrows, into the dark folds of a devastated world. And there, beneath the ashes, they waited and breathed. They weren't dominant, not yet, but they were ready. And so were the birds. For while the vast majority of dinosaur species perished, a small group, those who had already taken to the sky, who had feathers not just for warmth but for flight, survived. Not all birds made it. Many lineages vanished with the rest of their kin, but some, perhaps by chance, were small enough, adaptable enough, and fortunate enough to persist. They flew from dying trees to broken coastlines. They foraged for what was left. Grubs, seeds, bits of bark. Some may have flown long distances in search of refuge. Some nested in sheltered cliffs. They were light, mobile, quick to reproduce. And most importantly, they were not bound to any single ecosystem. They could follow the scraps of life wherever they still flickered. This is the moment when the story of the dinosaurs doesn't end, but splits. The Earth after the impact was not simply empty, it was transformed. In this quieter, leaner world, the survivors began again. And birds, humble as they seemed, would come to carry the legacy of the dinosaurs into every corner of the planet. Today, there are over 10,000 species of birds. They live on every continent. They nest on icy cliffs and in desert sands. They mimic sounds and solve puzzles. Some soar for days without landing. Others dive underwater, their wings slicing through oceans. They sing, they dance, they glide across wind like notes on air. And every single one of them descends from theropod ancestors. They are, in every biological sense, dinosaurs. It's a strange thought, that the chicken pecking grain in a farmyard shares ancestry with the likes of Tyrannosaurus rex, that the starling above the traffic lights, or the hummingbird near the patio flowers, is the result of millions of years of quiet survival. Evolution is not always dramatic. Sometimes it is subtle, feathered, breathing softly, watching, waiting. But birds were not the only ones to inherit the earth. In the shadow of extinction, mammals began to emerge, no longer just burrowers in the underbrush, but explorers of open space. With the dominant dinosaurs gone, ecological niches sat vacant, like rooms with the doors flung open. And the mammals began to fill them. They grew larger, they diversified. In the absence of predators like dromaeosaurs or tyrannosaurs, new predators evolved, mammalian ones, with sharp teeth and faster brains. Some mammals took to the trees, some returned to the sea, some, in time, walked upright. But all of this, the rise of mammals, the spread of birds, was possible only because something had survived, because something had held on. The impact was not a clean wipe, it was a filter, a sieve through which only the adaptable could pass. And what did adaptability look like? It looked like being small. Large animals need large meals, and when the food web collapsed, size became a liability. It looked like being generalist. The more varied your diet, the more likely you were to find something edible. It looked like mobility, the ability to move, to fly, to flee. And it looked like resilience in hiding, to endure when light failed, when ash fell, when heat gave way to bitter cold. These are not glamorous traits. They are not the kind of features that define heroes in stories, but they are the qualities that allow life to persist, to crouch in the dark, to listen, to endure. In that sense, the extinction event was not the end of the dinosaurs. It was the narrowing of the branch, a pruning, a selection for those few who could carry the torch through darkness. And they did. Birds not only survived, they sang. They evolved into new forms, filling forests and wetlands and skies. And in every one of their cells, in every hollow bone and feather filament, there lingers a whisper of what came before. The story of life is rarely linear. It bends and forks and folds. But some stories continue not because they are the loudest, but because they refuse to vanish. And so the dinosaur never truly left us. It wakes with the dawn. It chirps on city balconies. It migrates with seasons. It rustles in hedges. It preens its feathers in the rain. We live among them. And if you ever feel alone in the present, surrounded by metal and concrete and glass, look up. Follow the arc of a sparrow in flight. Watch a pigeon circle down to land. Listen for the rattle of wings beyond the trees. You are witnessing survival, not in fossil, not in museum, but alive and breathing. The world doesn't always remember in stone. Sometimes it remembers in feathers. Not the rigid kind that fossilize in sediment, but the soft ones, the quiet ones. The feathers that ruffle in the morning breeze as a pigeon lands on a railing. The ones that catch the golden light as a swallow dips low over a still pond. The subtle shimmer on the wing of a sparrow resting beneath your windowsill. These are not mere ornaments of flight. They are history, living echoes of a time before memory, a time of giants, a time of thunder. Birds are not just singers of the trees, they are the last breath of the Mesozoic, the soft, persistent whisper of an age that ended not with a bang, but with a long, patient fading. They remember what we cannot. When you see a bird fly, not just in wide arcs across skies, but in short, hesitant flutters between telephone wires, you're watching the continuation of a story that stretches across 160 million years. A story that began with scales and teeth, with tails that swayed and claws that grasped. A story that slowly shaped itself into lightness, into breath, into song. That motion, the flick of the wingtip, the curve of the back, the balancing tail, was forged in the heat of ancient jungles and carried through ash-choked skies. It was not invented anew, it was inherited, passed down, through famine and fire, through winters without sun and springs that never came. Birds are not an echo of dinosaurs, they are dinosaurs. And when you pause, truly pause, to watch them, you're not witnessing the present. You're sharing a moment with the past. Imagine for a moment the stillness of a Mesozoic morning, before the mammals had claimed the night, before humans had carved mountains for cities. A small theropod, feathered and light, perches on the limb of a conifer. Its head tilts, eyes bright, senses alert. Around it, flowers bloom, recent arrivals on the evolutionary stage. Insects buzz with unfamiliar wings. The dinosaur hops once, spreads its proto-wings, and glides silently to the forest floor, fast forward. Now, the world is paved. Trees are planted in even rows, and on a rooftop nearby a bird adjusts its feathers. It is smaller than its ancestor, lighter, more delicate, but its heart beats just as fast. Its bones are just as hollow, its eyes just as sharp. It is not pretending to be something new. It is simply what remains. There is a comfort in knowing that some stories do not vanish. They adapt, they reduce in size, they change costumes, but their core remains, the same pulse, the same mechanics of breath and balance and curiosity. In birds, the earth keeps alive a memory that is not housed in monuments or written in books, but carried in bodies. You're surrounded by reminders, the way a bird lifts from a branch with no hesitation, as if the air were always meant to carry it, the way a flock turns mid-flight, not like machines, but like thoughts, the way nestlings call from within hidden places, soft mouths wide, as if the world sang them song. Every one of these gestures is both ordinary and ancient, every one a reenactment of something that began long before language. Even in their silence, birds tell stories. Their beaks trace the lineage of toothy ancestors. Their feet still carry the structure of scaled limbs. Their lungs still whisper with the rhythm of a theropod's breath. To see them clearly, you don't need a time machine. You just need stillness. You just need a quiet place, a few minutes of attention, and a willingness to remember that the past is not behind you. It's beside you, perched on a fence post, hopping in the grass. We often think of extinction as final, but life has a strange softness to it. It resists ending. It bends. It flows through cracks, and sometimes it takes flight. Birds remind us that the earth does not always choose to forget. Sometimes it chooses to keep a fragment alive, not as a relic, but as a companion. And perhaps that's why we find birds in so many of our stories, songs and superstitions. Somewhere deep in our shared memory, we feel that they are more than what they seem. They are not only messengers between sky and soil, they are messengers between time and now. Every dawn chorus is not just a greeting to the sun, it is a choir of survivors. Every feather that floats down onto a pond is not just debris, it is the artifact of an unbroken lineage. And every time a bird lifts into the sky, it carries with it the weight of ages and the lightness of having survived them. So when you wake tomorrow and hear wings brushing past your window, remember, you are hearing more than a bird. You're hearing the Cretaceous, reimagined in colour and breath. You are hearing the persistence of life, not roaring, not stomping, but fluttering. Still here, still flying, still singing the story.